Hello everyone. Thanks for joining my session. I really do appreciate you taking the time. My name is Peter Lees. I'm Chief Technologist for Souza in Asia Pacific, and today I'm going to touch on some ideas around integrating and managing edge-based technologies at scale. Now, this is a very big topic, and we only have a few minutes, so I'm just going to look at some areas around how to deploy the operating environment and applications and how we can most make effective use of the technology that's available today. Now, I've been with Souza for about 8 years, but my journey in the edge environment really started back in 2004 when I was part of Sun Microsystems' Edge Solutions team. Many of the concepts and ideas remain the same from then, but technology has really moved on in a big way. And this means that a lot of the applications that we're seeing today can really take advantage of much greater power and capability of the devices that we push out to the edge. And the solutions that we find to deal with that reflect that increased power and capability. Before I get into that though, a little word about Souza. Souza is the world's largest independent open source software company. It was founded in Germany back in 1992 and had its headquarters here in Nuremberg. Souza was the first company to introduce Linux as an enterprise operating system and has over the years has built on that foundation to incorporate all parts of what we call the software infrastructure stack. So that includes the operating system, containers, embedded devices, management, and so on. And with that in mind, it's given us some insight into how customers are using systems at scale. A lot of the customers that Sun have in Germany are manufacturing organizations. There are some automotive manufacturers as well that are looking at embedding software into their devices, millions of devices, as large as central computers, but as small as tiny ARM-based Raspberry Pis. And this helps us give some idea of the scale and what the software and hardware challenges are when looking at edge computing. Because even though edge devices aren't new, as I said, it's been around for 20 years or so. They've previously been relatively lower power devices, single function, point of service devices, kiosks, that sort of thing, maybe branch servers. But now they're in, edge devices are cars, they're light bulbs, they're virtually everything. And as I said, a lot of this new functionality is being driven by advancing capabilities, the miniaturization effect of CPU technologies, the increased number of CPU cores, low power capabilities, network capacity and throughput is vastly increased in the last 20 years. And all of these are driving some of the challenges that we see. Essentially, the devices at the edge of the network are becoming a lot more sophisticated, a lot more capable. But at the same time, we have to balance that against other needs. We have to balance this against reliability. No one wants to see this kind of environment in their edge devices, right? So there's a balance there between capability of the devices and the simplicity required to make sure that you can use a field replaceable unit, plug in a new device, have it assign itself into the network, get the right software, get the right applications, and then start doing the work it needs to do. And this is combined with an evolution in the platforms. I mentioned ARM before as one low power alternative that's becoming very popular on the edge. But this evolution is constant, is continuous. So we have almost the Harbour Bridge painting problem. As soon as you have rolled out an entire platform, an entire environment, you need to start again and look at what's the next generation of technology and how can that be applied. So when you're looking at an environment to roll out your operating systems and the applications that run on top of them, you need to consider how are we going to use this management platform in multiple different hardware architectures. Is it going to be future-proof, or are we going to have to rip and replace the whole environment just when we want to make some change to our underlying hardware or underlying devices? Ideally not. You want to be able to have a generic enough base image, generic enough base operating system that you can then apply additional functionality on top of that, even though the underlying device might change. So one example of this is one of our customers in Asia is looking at changing their entire ticketing management system for public transport. So currently they're running on one particular platform. They have very fixed use devices, but they're looking at changing to a next generation hardware, next generation set of applications and capabilities. But they want the user experience, the customer experience, to remain the same. You know, they've distributed smart cards to the entire population. So those smart cards need to remain viable even though the rest of the hardware and the rest of the systems are changing. So that evolution, being able to keep that in mind, is a very important part of dealing with edge at scale, because you can't just roll back in the way that you could if you only had a few dozen or even a few hundred computers. When you're talking about millions of devices, you need to have evolution in mind. And then, of course, the larger number of devices you have, the more likely it is that you'll be affected by some kind of security exposure. So staying on top of these is absolutely key. Having a system that will not only automatically apply patches to security problems, but also give you an active feedback loop to tell you if something has changed or if something is still open to exploitation, is a very important part of managing that environment effectively and making sure that you don't end up with this kind of sad face on your edge device. So that's talking about the base platform and the operating system. What about new applications? With these new capabilities, obviously the new power of these devices lets us do a lot more than we used to when we were talking about the smaller, more compact edge devices of the past. Those edge devices used to be updated with firmware perhaps, or maybe just left to rot and become security nightmares. But now, you know, things like, you know, the smartphone show just how capable a very small form factor edge device can be. And obviously the great power of edge computing now is being able to adapt and change the functionality on those edge devices, making them multifunctional. It means the edge device is no longer a single service, single function device. It is a platform that we can deploy new ideas and new concepts as they come up and as they are needed within your organization. So what we're talking about here is really decoupling the application layer, the application environment, from that underlying base image that I was talking about before. And these days, the modern way of achieving that is through containerization, or the use of containers. That is, building the functionality of your application into small components which then can be deployed on top of a platform regardless of what's running underneath. One of the great advantages of container technology is that the development environment and the production environment can look exactly the same. So the application itself doesn't really know or care or have any differentiation about whether it's being developed on or whether it's actually being deployed. And this enables a very rapid turnaround from new idea creation and coding into actual production and running. So this leads to why 60% of organizations are either deploying containers already or looking at doing so in the very near future. Now, containers are great. I mean, they allow you to encapsulate your functionality, but typically you end up running with hundreds or even thousands of them in a cluster in order to build up a complete application. And that's where Kubernetes comes in. Kubernetes is the management environment that coordinates all of these containers working together. So, you know, if containers are sheep, then Kubernetes are the sheepdogs that round them all up, make sure they're doing the right thing, going the right direction, and make sure that they're working the right way together. Now, Kubernetes started off as a data center deployment tool, but new advances in lightweight Kubernetes, such as K3s, allow deployment onto very small platforms. Things as small as a Raspberry Pi, which is a very small ARM-based server about the size of a deck of cards. And these small platforms can now be Kubernetes clusters, a single node cluster, which allows you to run multiple applications on top of it with all of the management tools required. So decoupling your application and using Kubernetes on your edge devices allows you to change the functionality as and when you need it and add new functionality when it arises. So that's about making the platforms more functional. What about accelerating that deployment? How can we actually get that running as fast as possible and deploy as quickly as possible to potentially a fleet of hundreds or thousands or even millions of nodes? Well, that's where tools such as continuous delivery and microarchitecture come into play. Microservices architecture allow you to create specific functionality of your application in a very small unit. So all of your functionality of your application is broken up into individual units, individual components, and those components can be changed and adjusted without affecting other components of the application. What this means in practice is that you don't have to wait for an entire application to be updated before you can release new functionality. If you want to create new functionality for one small component of your application, you can do that using this architecture, deploy it as a container, and then incrementally improve an application rather than waiting a long time for an entire release to be available. You couple this with continuous delivery, where the application or the component is pushed out into production as soon as it runs through some automated testing. And that gives you a way of making sure that your edge environment is always up to date, always has the latest materials, always has the latest application, and has the functionality you need. And then you can use a technique like GitOps to actually push that to thousands or millions of nodes. GitOps lets us define policies for how the applications, resources, security, and so on work within a clustered environment, a Kubernetes cluster environment. It basically lets you set that policy, keep it in a repository, a Git repository, and then when that repository is updated and approved, that policy is then deployed throughout the network of all of your clusters. So this is a very scalable system that you can start from a central node, as you see here in the diagram, defining a bundle, which is essentially the capabilities and components within a Kubernetes cluster, and the application and the latest version of the container, ship those all out to separate groups, and then spread out throughout your network from those control nodes out to the entire fleet. So this is technology which allows you to not only make sure that you can get the latest applications out and ready, but also gives a facility for rolling back quickly if there is a problem. So all of this, again, is happening at the edge. We're taking the capabilities of those edge devices and the capabilities of Kubernetes, that platform, in order to give us the ability to do logical pushes within the edge environment rather than having to do everything from a central point, which could take a long time. If we have to respin an image, for example, and push it out to individual edge devices, do that a million times, and it can be a quite time-consuming exercise. What we're talking about here is actually handling some of that application lifetime and life cycle at the edge device itself, taking advantage of that Kubernetes platform. So I've talked about quite a lot there. I talked about deploying to multiple device types, to having the idea of looking forward to the evolution of technology and making sure that you have a platform that gives you a feedback loop about whether the security of your underlying platform is still valid. We talked about how we could treat edge devices as application platforms, decoupling the application and the operating system, which allows you to deploy new functionality. And then we talked about how we could do that at scale, using GitOps to develop policies that we can then push out to the edge devices that can then be used to apply the lifecycle of the application at the edge rather than just doing it from a centrally commanded spot. So just touched on some ideas, of course. To find out more, we have a couple of white papers here that you can look at. The QR codes there should take you to those URLs. Otherwise, if you do have any questions, I'm more than happy to answer those in the chat or in the other session. Otherwise, I'm very happy that you were able to join me today, and I'm looking forward to talking to you again during our panel session later on. Thank you very much, and bye-bye for now.